All right, hello everyone. Hello everyone. It's January the 3rd. All right, let's do it. Oh yeah, we still. I checked the hints yesterday. Thought about it. Still no idea, but I may have a new idea. No, I said I have no idea, but actually I kind of do have a new idea regarding prefix sum. So that's something we're gonna try today. All right, and dear me, let's hope this works. If this still doesn't work, I really have no idea. I think if today I cannot solve it, we're gonna go look for the results. Right? It's been way too long. It's just dragging on and on. But I have high hopes. Okay, I have high hopes for this final method. All right, let's take a look at this. Minimum number of operations to make array. Is this something we've done before? You're given a zero index. Oh no, that's 2,800. That's very late, very recent. You're given a zero indexed array, nums, consisting of positive integers. There are two types of operations you can apply to the array any number of times. Choose two elements with equal values and delete them from the array. Choose three elements with equal values and delete them. So either 2 or 3. Return the minimum number of operations required to make the array empty. We can do once, twice, 3 times, 4 times. Okay, so we run through the whole thing and we'll count. Right, we have a counter. And for the counter that are divisible by 3, we'll remove them just by 3. If it's not divisible by 3, then we'll do depending on the remainder, right? If it's divisible, if the remainder is 1, if the remainder, because it could be 0, remainder is 0, we just remove everything. Remainder is 1, that means something times 3 plus 1. It may or may not be, no, it is divisible if it's remainder by 1. That means we can do whatever number of 3s, and then the result will be, we can do 2, because it's basically we take 3 out, so it'll be 4 as something multiple of 3 plus 4, right? That one is remainder by 1. And of course it cannot be 1 itself. So if the remainder is 1 and it's larger than 1, then we'll do divided by 3 the quotient plus 1. If remainder is 2, oh dear me, remainder is 2, that works as well. It's quotient plus 1. Right? Yeah, so it's a 2, 2, 2, 2. We have 4 2's. It should be divided by 3 as 1. 1 plus 1 is 2. So it's 2 and 3 and 4. So yeah, it doesn't matter. We always divide it by 3. Doesn't matter. Unless you are 2. Right? If you're 2, you're just 1. If you are 1, something is just 1, that's impossible. Okay. Let me bring this one in. See, these are fairly easy, which I really, don't understand why the other one is so hard. Just 3 days, okay? It's just bonkers. 3 days efforts, and still probably not enough. Anyways, we need to do a map of integer and integer. Can we count it? Counter new map, hash map. I think I got a new hash map. And then for int n of nums, counter dot put if absent n 0, and then counter dot no, that's not right. Should shall be put n and counter dot get if get or default n is 0 plus 1, right? That is that is the counter. That is the counter, right? So now we have the counter. Then we just go through the counter one by one, and we need a result. And now we say for value, we can say int v of counter dot values. If v is equal to 1, we'll return -1. If v is equal to 2, it's actually fine. It's actually fine. We don't need to check v equal to 2. All we need to do is res e plus equal to v divided by 3 plus v mod 3 is equal to 0. Right? If it's equal to 0, it will be 0. If it's not equal to 0, it will be +1. And then we'll return res. Okay. It works. Looks like it works. It works. Looks like it works. Yeah, seriously, some medium question is very easy and some medium question is very hard. It's toss. Do you still remember what I think it's 2870? Yeah. All right. Count the frequencies, right? Count the frequencies and compute and then compute and divided by 3, right? Depending on the remainder, yeah, hold on. If there is no remainder, the number of operations is the quotient. If there is one remainder, then we can reorganize the number as n. Now then n minus 4 must be divisible by 3, and the remaining 4 can be handled by 2 2's. If there is 2 remainder, then the remainder itself can be handled by 1 2. That's it. All right, how do I open a new? No, it doesn't have it. Open document, search, rename. Actually, I have no idea. Like how do I open? Shoot. You can open new file. New. Okay, so I can do new. Oh. Okay, hold on. Let's quit it. I'll do this. 2024. Alright, 2024 foro.java. Now I haven't installed the Java thing yet, so yeah, this is basically, this is not right, but it's okay. Right, it's okay. And what I want to show is I did install one of them. Okay, I did install one thing. We'll see. We'll see. Counting. Math.co. That's actually a good idea to CO. Alright, we're done with this. Okay, and this one is done. We can say vert. Nope. Not an editor command. It has to be new. Well, how do I open open file? Right, open. Oh, if it's a file you already have, then you will just do search file. Ugh. What's this? 2772. .py. Oh my god. Oh yeah. Oh. We do this. Why is it not opening? Oh, is it still opening? I think it's dead. I think it's dead. What? Oh my god, it can take... Why did it take even longer? Look at that. Look at that. K is not accessed. Well, what are the H? What does H mean? LSP. H. What does H mean? Oh gosh. H for warnings. H for warnings. Okay. I need to unblock Reddit. But H is for warning. Oh yeah, there's warning, right? N is not accessed. See, this is interesting. We're gonna do math dot, right? And I can, I remapped this. It's supposed to be N and P, and I'm doing N and P right now, right? But I remap to J and K. It just only makes sense, J and K. So this actually looks almost identical to Sublime. So the only thing that I cannot do, which I want to do, is can I create a separate... I mean, I can split window. Can I say split window terminal? Is it possible? Yeah. Terminal. Huh. I can. So I do terminal. That's not what we want. Oh my goodness. Oh my goodness. Terminal. Okay, so what I want is, if you want to split the window vertically, I gotcha. So how do I quit this? Dude, how do I quit this? I I cannot do Control W. What the hell? And it's super slow. How do I turn it off? Control W N. Wait, hold on. Wait, hold on. I can go to the bottom. Oh, but I cannot exit. I cannot Control W N. But I cannot. I cannot. How do I exit terminal mode? Oh, Control N. Why you say Control W N? If I say Control W N, that's Control N. Control I. Wait a second. It's Control / and Control N. Dude, this is bonkers. This is as bonkers as it can get. Right? How do I exit? Q. Job still running. Which is fine, right? We exit. So I'll first do a vertical split. You know what? I don't like this idea. So I do Control W, quit, and then Control W. I just do a split, and we go bottom, and then we say term. Now we go to terminal. Dude, it just takes so long. Right? And do Python LeetCode. I don't know. I know the file name. File name is 2772. I run it. Failed. Do you think this is the best way? Do you think this is the best way? I mean, just look at this. This is unusable. Alright? This is unusable. It's super duper slow. And this is all within Vim. Like I can't handle this. It's way too slow. So if that's not the case, then we will have to like go here. Okay, so I'll just do, I think it's desktop, right? I think it's desktop. Yeah. I mean, it's not the fastest, but at least it's better than the other one. So I can just, so I guess I just switch back and forth. I don't know, why is it so slow? NeoVim terminal slow. Do you want to deal with this? Clicking has to repaint the screen rather than scrolling. You know what? Screw this. I am not going to be on that heel. I will Control W and break out into a new tab. Oh. Damn, you can do that. Hold on. So we can go J, H, L. Wow. Oh, but that's the same buffer. They're using the same buffer, so they gave you the same result. But that's not what we want. Let's just now I have to exit it first, and then we do this, and we'll quit. That's just one, and we'll do this and quit. Okay, so what I want to do, I'll just go here. Okay, let's go small. So now we'll have 2. Right, now we have 2. That's fine. We'll switch back and forth. I don't think it matters that much. We just switch back and forth. Or, there's no or. Or I can do split screen inside term. I think they have split screen as well. View. Window. Split. Resize. Yeah, I'm not sure. Maybe Tmux. I don't see split screen here. I believe you can like say this to here. No, I want this one. Oh. Hold on. Shell new tab. Split horizontally with current profile. Okay. Yeah, that's the one, right? But how do I go up and down then? That's a good question. I honestly don't know. Yeah, I can Tmux it. Window. Select. Next pane. Control. No, this is Option Command Up. Option Command Up and down. Ah, that's fine. I can do that. I can do that. So I go this up, down, up, down. Yeah, this kind of deceiving. This is up. This is down. Okay, so we're gonna go to desktop, LeetCode, and we do Python. There we go. Then can I increase and decrease its size? Resize window. Yeah, that's fine. I just resize it. So we want this to be small, like this, right? And go down, go up. So every time if I want to run stuff, I'll go down, and then we will run it, and it will fail. Then I'll go up, and yeah, not too bad. Not too bad. Not the best setup, but you know, it's all right. Let's see if this setup works. Okay. Maybe I should read more, like what will be the best setup for this. But let's just do this for now. Okay, let's just do this for now. Okay, so what we're saying is, let's go to here, a prefix sum. Okay, and I'm trying to see if the prefix sum is gonna work, and I need to use my example. Where is my example? This is an example, right? I pull this up here. So we have, 60, 72, 87, 89, 63, 52, 64, 62, 31. Okay, so the idea still is I need to know to check if the current one is correct. I just need to know when the previous is 0, is the current positive or negative. That's it. So we do a prefix sum, which I can actually let's actually just do a prefix sum. Accumulate, right? So we can do import. No, not import. From functools. Ooh! Tab is doing this. All right. So when you do this from this import, wait, hold on a second. You don't have anything? Come on. Import what? Import accumulate? No, it's not functool then. Oh, it's a tools. My bad. It's a tools import accumulate. Okay. So let's not do this. Let's just do print accumulate nums. Actually have to save, right? Then we go down and then we run. Yeah, that's wrong. That's okay. So we just do a list. That's wonderful. Good poop. And we do this. Okay. So we have 60, 132, 219, 308, 371. This. 371, 423, and 487. Okay, let's just say this is all we have, right? So to know what this is going to be when this is 0, I'll minus 60, right? So you see this one become 12, which is fine, right? And then to see this, and then you need to do this. So you need to minus 132. So this one minus 132. Oh, hold a second. You don't minus 132. Because this is 219, right? 219 is this plus this plus this. And then we are at here. And what we need to know is, so we do this, and this become 12, right? You know this has become 12. So we say accumulate wise, we have 60 so far. That's what we remove. And then here is 12, so we say accumulate wise, when we do this, should be this plus 12. But then, now when you minus 60, this one, yeah, is 60. And then, so the first round, you say you're minus 60. So you know, everybody that I know, you need to minus 60. And this position is more than 60. No, I don't think so. No idea. I don't think it's right. Mm-mm. Don't think it's right. Like if I can know how much in total, right? Like for 87, when these two become 0, what this value should be. And I use prefix sum, right? Which means, and then this I need to be 60 times 2. Because I remove 60 here, remove 60, actually times 3, right? I mean, it'd be 60 times 3. So minus 180. That gives you 29. Now 39. Mm-hmm. And then you minus 12 times 2. And here you know it's going to be 12 times 3. Because this is the start. But how do you keep track of what's the total number of minus? And all of those will be 12 times 4. See, that is the problem. Right? Because I want to walk them one by one. And even if I know how much, you don't know. That's the thing, you don't know. Yeah, no idea. Alright, I give up. I'll check. Greedy and sliding window. Alright. Pretty simple. Sliding window. Huh? Window elements. K equal to 3. Current 0. I don't understand. For the first A line, we need to select the array and then decrease all elements by this. Okay. The subarray deleted starting at AI will affect all of these. So we can use a current to record the sum of previous k-1 elements, where current is AI minus 1, AI minus 2. So there is a sense of sliding window here with window size k. Now solve this problem where we iterate AI and compare AI with current. If current is larger than AI, it means AI will be over decreased to negative. K equal to 2 will return false. If current is smaller or equal to AI, it will be decreased current times. So AI minus equal to current, and still need to decrease AI times. Huh? Wait. Hold a second. Current record the sum of previous k-1 items. Previous k-1 items. And then we look at AI. If current is larger than. Okay, so let's say this is K, okay? We have K items here. And this is I. This is the last one that we're looking for. And then this, we have a sum of them. What is the sum? We minus the first one. And then we reduce the second one. Reduce third one, reduce fourth one, reduce every single one. And they all affect the last one. Okay. Okay. So we say if we add them together, and if this is smaller than this, which means we over decrease and we false. Otherwise, it's good. And then this will minus the sum. That will be the new value. That's what we are looking for. That's what we're looking for. That's what we're looking for. And then what? Right, that's the new value. And then if we're going forward, then the next one, when it gets removed, I will plus this. Because that's the amount will get removed for that, for this one, for the next one. So we compute the previous, right? We compute the previous because ending, right? We're trying to say ending at I after everything previous becomes 0. What is this I value is going to be? And so we say ending I here, right? What is the previous value can be? But when I was trying to say, okay, I cannot do 60, I cannot just do 60 plus 72 plus 87, that's not right. Because each one has to be modified first. Therefore, if we modify it by going from the start, if I going from the start, we say 60, okay? To look at 60, I need to check its previous sum. The total amount decrease is 0, right? Therefore, for 60, I will decrease by 0, so it remains 60. And then, now, I'll call pre will equal to 60. Because we need to make this equal to 0, so we remove 60. Now we look at this. Is the pre smaller or equal to? Yes. So for this one, I say I need to, because the pre take away, so it becomes 12, right? And then this will plus 12, now it becomes 72, so it becomes 72. Now here is good, so 87 minus 72 is the 15, right? And then now plus 15, that's 87. This becomes 2, that becomes 89. Now it's 63. So when the first, everybody becomes 0, right? When first everything becomes 0, what this is going to be? It's going to be 2. Wait, hold a second. That's actually not... That's become 89. That is not right. That's not right. But then when we hit here, when we do this, then this one is eliminated. So now the pre, is it become 29? Because we do minus 60. So we say this become 29. Because I need to minus this to face this. So if it's 29, then we say 63 minus 29 is 34. And a 34 plus 29 is going to be 63. Of course, because you compute this. And then this need to minus this. Now become 22. Now I have 52. So I minus this becomes 30. And 22 minus 15 becomes 7. That's not right. That doesn't feel right at all. Because I remember, maybe it is 37, right? Hold on. It's 34. 34 is correct. 34 is correct, but when we go to the next one, this one becomes 1. So 34 is correct. So we need to add 34. $29, and this one is something on 34. And 34, 6, 51. Oh, hold. This is so far so right. This, hold on. Let me redo this. Right, this is this. And then 89, I check the previous this. It's 87, so I minus become 2, right? And then this become 89 again. Now 63, I need the sum of the previous 3. Because these are what it looked like, right? After done this. Yeah, after we become 0, this will become this. After this becomes 0, this is after this becomes 0, this is this. So we add these together, which is 89 minus 60, which is 29, right? 29. So this minus 29 is 34. And we do this sum put together. I think that's 63. The pre here is this, right? That's 27, 29. And has to be 63. No, it's not really. The pre should be this sum, right? So like here, the pre is yeah, for here the pre is 87, right? This, okay? So now for here, the pre is not 89. I shouldn't say 89. The pre, because I moved to the next one. Right, I moved to the next one. So I need a sum of these three. So I know the sum of the 4. Right, minus this. So this shall be the sum of, from here, go back 3 positions. That's 29, right? And then based on this, I compute this. Now it's going to be 29 minus this and plus 34. Right, 29 minus this, it'll be 17. 17 plus that'll be 51. And then this will become 1, right? That'll be 51 minus this plus this. Ah, I see. That'll be 36, right? 36, that'll be 37. Because 51 minus this 36 plus 1 is 37. Now 64 minus 37. That's everything the previous add together, because this is what they are when everything in front of them becomes 0. Right? So for this to become 0, everything in front need to become 0. So you need to add these together. So these are the ones that you will have to remove. And for this one, 64 minus 37 is 27, right? That's 27. Now it's 37 minus 2, 35. 35 plus this is 62. Now this becomes 0. So this will be 62 minus 34, right? Minus 34, which is 28. And then this is 31. Minus 28, this will be 3. And this will be 28, this will be 27, so this will be 30. So what's the one next to 31? 37. So yeah, I guess so, right? Okay. This is not it. So basically what we're gonna do is we're gonna have a pre is 0, and then we're gonna say for I and in enumerate nums. Okay. So I want the pre to be the sum of the k minus 1 in front. Therefore, what we're going to say is if, but we need a j, right? We need a j. Oh, we don't need. We just, the one we remove is going to be this minus 1, minus 2, minus 1, 2, 3, right? Minus 3. So it's going to be j minus k. J minus k plus 1, right? J minus k plus 1. So j minus k plus 1. We just say if I minus k plus 1 is smaller than 0, is larger equal to 0, right? Then we say pre into minus equal to nums I minus k plus 1, right? Otherwise, we need to compute Or do we, no, I think we first check. We say if 3 is larger than n, that will return -1. No, return false, right? I need to. Yeah, return false. So that's return false. Hold on, I need to also do this. Fail. Oh. Oh. Oh, what the hell? I have to read the solution. And here is Lee215's version. The idea is to keep track, is to find, right? Is to find is that given a subarray of size k, to make the kth value 0, we need to no, I don't like it. For nums I, to ensure that nums I can be reduced to 0, we need to know how much, right, needs to be removed from nums I when when all the values to its left are reduced to 0. Now, since only the k-1 counts of numbers to the left of nums I affect the value of nums I, right? And the amount reduced is equal to the value of those numbers when their predecessors are all 0. Thus, we keep track of a sum of a window of size k-1, right? And if that sum is not bigger than nums I, then we can reduce nums I by that amount, right? By that amount. And then we add the new nums I to the amount, to the sum. Then we reduce the sum by nums I minus k plus 1, followed by adding the current nums I to the sum to form the new sum for nums I plus 1. For the new sum to check for nums, we do this until all nums are visited, and at the end the sum should be 0. Yeah. I don't think I can come up with this with even more time. It is a very hard problem for me. Anyway, this is ON, So let's just freaking great. All right, if this is larger than, then we done. All right. Otherwise, we do this. We'll remove, and we'll say nums I minus equal to pre, and pre plus equal to num I. No. With here, nums I will minus equal to pre, because the pre is the previous k minus 1. So we do that. And then we do this, and then we'll do this plus equal to nums I. And we'll keep going. At the end, we'll say return pre is equal to 0. You are kidding me. That is way too easy, man. Hold on, we do this. We go. Oh, I think this is correct, man. I think this is correct. Oh, that's the other issue. Oh. The yank does not go to... Oh, it does! It does. The yank does go to... what the hell? You put it in Java. It does. The yank does go to the copy board. Oh my god. This is so good. Nightmare. This is one of the nightmare problem. All right, let's just cancel this and move it down. And we need to duplicate it. Let's go to next. What? All right, so I want to next time do this. Okay, let's figure this out. But hey, that's it, right? That's it. Yeah, it's actually not too bad. Oh, I always press the wrong key. Oh, I like this left and right. Ah, but this is split screen. All right. Anyway, that'll be it. That's it for today. I will see you guys tomorrow. Adios.